Here are two small balls, identical in size and weight. One is a dimpled golf ball, and the other is smooth. If we roll both balls down a slope from the same height, the smooth ball travels farther. This is easy to explain because the smooth ball has less surface friction. However, if you shoot both balls with the same force, the golf ball travels much farther, nearly twice the distance. The dimpled surface of the golf ball creates more air resistance. So why does it fly farther? When a smooth ball flies through the airflow around its front is smooth and regular, known as laminar flow. This part is fine because laminar flow has low friction with the object. However, because of this, the airflow easily separates from the ball's surface at any turn, creating a large low-pressure area behind the ball, which exerts a backward force called pressure drag. On the other hand, the dimples on a golf ball create turbulence. Although turbulence increases friction with the object's surface, it has a beneficial side effect. It helps the airflow stick to the golf ball's surface even after turning, reducing the low pressure area and thus decreasing pressure drag. Wind tunnel tests show that the drag coefficient of a smooth ball is 0.47 cd, while a golf ball's is only 0.24 cd, half of the smooth ball's. Given that dimples can so effectively reduce drag, wouldn't it be more fuel efficient to design all vehicles with a golf ball-like surface? Compared to golf balls, reducing a car's drag coefficient by just 0.01 cd is a significant achievement. Engineers place vehicles in large wind tunnels and continuously tweak the shape of the car and its parts to optimize and reduce drag bit by bit. For example, research from the China Automotive Technology and Research Center shows that changing the shape of mirrors, deflectors, wheel hubs, and headlights can reduce drag by up to 25.1%. However, this result still doesn't match the reduction achieved by a dimpled surface. So why don't engineers just make the car's surface like a golf ball? According to NASA, engineers haven't adopted dimpled surfaces to reduce drag because the drag reduction for a golf ball is conditional. It only achieves half the drag coefficient of a smooth ball at speeds around 260 km per hour. Beyond or below this speed, the effect diminishes. This speed is too high for cars and too low for planes, which is one reason why cars and planes don't use a golf ball-like surface. Streamlined objects naturally maintain airflow attachment, resulting in a drag coefficient much lower than spherical objects. Adding dimples would increase their surface area and friction, making this drag reduction method effective only for spherical shapes.